Hello everyone and welcome to the next tutorial about the HRV toolbox. So in this tutorial you will learn more about the graphical user interface, about the different panels, how to import data, how to save settings and make some adjustments, and how to export data. So let's start and open HRVTool in Matlab. It will automatically start with an example dataset. So here you have a record taken from the Polar Watch, so it's an HRM file. So here you see the file name, and you can assign a title to that file. So here in the upper menu, you have a button for giving a title. So this is sports. So let's write sports, and let's have a look at the data. So the HRM file is storing only the Polar Watch is storing only the interval data. That's why you have here the impulse data. So these are the annotations of the QRS complex. So there is the heartbeat annotated, and you can click on that button here on the right hand side, the interval button, to display the interval lengths in seconds, so 0.87 seconds, then 0.9 seconds, 0.87 seconds. There's another button, proportions, which will show you the relative changes from one interval to the other. So when it's getting larger, then you have a positive value, and when it's getting lower, so when the interval length is decreasing, so the heart rate is increasing, then you have a negative value here. There are two buttons here on the right hand side. The forward button will just print the next interval, so the 10s to the 20 seconds, the 20s to the 30 second, and this fast forward button will skip the next 5 intervals and will show the 6th interval. If you want to look at a different interval, just type here in this edit field the time in seconds, so 120 seconds to 140s. So this 20-second view, you can have here in the middle left-hand side the HRV measurement, and there you can observe also the heart rate. And here the local heart rate, here in the second column, is 65 beats per minute. So the units of all these measurements is written when you go with your mouse over these column names. There you see the units. Okay, another way of, there's also another notation accepted. So this is the second minute. So you can type 00 double point 0200, which means hours, minutes, and seconds. And then dot dot 00 second, minute, and 20 seconds. Yeah. So when you press this button, this forward button, back button, it will preserve your notation. The intervals you see here in this local view will be displayed in this middle panel here as a local return map of our intervals, either the values in percentage, so the relative change, or when you press this button here, in seconds. So this is the ordinary Poincaré map. There are some buttons which are quite useful. So here you can show the number of coordinates. This is the first coordinate is 1.01 seconds to 1 second, and then you hear it's very steady there. It's 1 second all the time. So let's scroll to a better interval, maybe this one, and here you can observe some kind of periodicity of the signal. So the interval will increase and decrease according to the respiration, and this will cause some movement here in this Poincaré map. And this will happen also in the relative map, but it's more dense. It comes more clearly while looking at the relative changes. you can animate this local view. So you can set here some time-lapse factor of 5, which means that it's 5 times faster than the real time, and click on this animation button and you will observe here this kind of periodic structure. So maybe you're interested in these kind of structures, so you want to label this kind of segment. So therefore you have here this edit field on top. Just gave a name to it, so this is resting 1, let's say resting 1. And this name will appear as the column name of this local column, and it will appear also here in this lower panel here, where you can follow the whole time series here, and this record is up to 2 hours and 40 minutes. You want to compare this kind of short segment to another segment, therefore you have this kind of footprint button, which will store this segment as another column, the footprint column, along with the name and the time. So let's scroll to the next interval. And you will see here in the local return map that you have in gray the footprint, and the actual scatter plot is overlaid here as these black bullet points. And here you have the local column. You can name this. This is resting 2. And you can compare the different HRV measures. So the local heart rate here is 60 beats per minute, and there in the footprint it was 62. It's comparable. So the mean RR intervals here about 1 second. There it's 966 milliseconds, but the HRV parameters are different. And you see that here also that the scatter plots is more dense here in the second interval. And yeah, you can search for the courses. Okay, so here in the lower panel you have on the left hand side the segment-wise HRV analysis, and also the heart frequency as a red line there. Here's the visibility on off button, so press that and then click on these different lines you will want to delete from that plot, and a double click will end the selection. So here we can observe the heart rate and follow the heart rate, which is about it's about 60 the first 20 minutes, and then it goes up while doing sports up to 165 beats per minute with some breaks in between. For additional parameter, the triangular interpolation of an intervals, you can compute them to add this to this plot. This is not default because this takes some computational times. Here on the right hand side you have the global return map, so the Poincaré map of all recorded R intervals, and you will have blue points and red points. These red points are non-normal intervals, so there is a filter. I tell you more about the filter, the automated filter function in the next tutorial, but these were cancelled out from the computation of our HRV measurements. You have here the picker function, so when you are interested in some special coordinate, some special pair of R intervals, you can do a double click at some point there, and it will jump to the local interval. So, and there you can clearly see that that some R intervals are missing there, and therefore it is replaced by NaN values, so not a number of values. So this is cancelled out from the calculation of the HRV measurements. There are some outliers here in blue, So let's go to that kind of interval there. And there we have this interval. We have a very long interval there, which is 1 second. And the previous interval was 0.7 seconds. That's why we have an increase of 37%, followed by minus 12%. I would say this is not caused by some artifact. This is maybe causes a respiration or some kind of arrhythmia. When you want to go, if you want to go back to the resting state 2 or 1, you can press the selection button there and just click on this interval there, and you will jump back to the labeled interval. So resting 2. So for resting 2, you have these local RR tachogram here and the corresponding spectrum, which is not very accurate because it depends only on a few intervals. It's better to analyze this with at least 5 minutes of recording. The global view here will show you all the different R intervals within these 2 hours and 40 minutes, and the spectrum of these spline interpolated RR tachogram with the low frequency value and high frequency value there. Therefore, you need unfiltered. It uses unfiltered data. So let's import another data set. So click on this open button and let's look at some EDF file. So I have recorded some for you using some medical device. So it will recognize the different signals stored in these EDF files. We want to look at the EKG1 file. And we get the notification if you want to load an annotation file. If you have some file, you can directly load it. Otherwise, the heartbeat detection starts with the different settings. So we have a human ECG. We use the fast setting because we want to show you the results very soon. And it will, for every 5 minutes of the ECG, it will annotate all the beats. So here we have 104 different 5-minute segments, and whenever the tool is running some analysis, it's turning red, and if it's finished, then it's gray again. So now we have the notification to save the annotation file. Yes, we want to do that, and yeah, it preserves the name of the file. It gets some N to it, and it will store it as a MAT file. Okay, so this is the interval data, but now the EDF file contains also the waveform data, so we can push this waveform button there to look at the ECG. This looks a bit noisy at the beginning. Maybe this is not the best record I have made, but it shows that also the filter function works quite well, but also the annotation. So here we have a very noisy part, but it still recognizes the QRS complex. Okay, I will tell you more about the tool strip here. So we have this open file. This is what you know when you want to load data. Then you have the save file to save the settings we made. So for instance, we have labeled different parts of the ECG. So label 1, or what kind of buttons we have pushed here, what we have enabled and disabled. All these things will be stored in some settings file. So let's click on save, and I will show you later what happened. Then you have this printing option here to print the view as PDF, you have these zoom buttons to zoom at some part of the ECG, or within the global return map, or within every plot you see here. The same accounts for zooming out. Then you have this pan to scroll, to shift the data a bit here, make some adjustments. Then you have this data cursor to show the coordinates. You have the brush to highlight some scatter cloud, for instance, or some part of the ECG. For instance, here the T wave. Then you have here this clipboard option. This will copy all the HRV measures. So you can copy them to a text file, or just to copy them into the into Matlab console. Then you have here the settings, so you can adjust the text size, for instance, and the text font. This will affect all text you see here in the graphical user interface. So now we are going to look into the working directory and want to see what happened, what additional files we have generated. So this was the EDF file. This was the name of the EDF file. And we imported the data and generated some annotations. Yeah, there was a heartbeat detection running, and we stored the annotation file. This is that file here, the MAT file. So when you import them in Matlab, you will have this annotation vector, which contains 35,000 heartbeats. Yeah, so you can work with them. Then you have these font settings MAT. This is a structure which contains the font settings. So we changed the font size from default to 14. Yeah, I will delete them because it was just to show you that you can do that. And then you have the settings file here, settings.m, which contains the settings particular for this data set we have looked at. And there the title has been stored, the labels for the different limits, and you have all these enabled or disabled buttons, and also the marker size, the line type, everything is stored in this settings file. So whenever you load, you import your this EDF file again, it will read also the settings, and you will get the view you saved the last time. Yeah, I hope I have answered a lot of questions concerning the interface of HRVTool. The next time we are talking about artifacts and filtration, about continuous HRV measurement, and we will set up batch jobs. So have fun in experimenting, and we will see us in the future. Bye.